Okay, so the last topic in this unit is spheres and hemispheres, with their surface areas and volumes as we've talked about all week. So first off, what is a sphere? Well, a sphere is a ball, basically, or by definition is the locus of all points that are given distance from a given point called its center. So it's very similar to a circle, except for it's in 3D form. A great circle is when you cross a plane in a sphere. So it's its cross section is called a great circle. And the biggest circle is when you go directly through the center, and that's why it's called the great circle. If we cut a hemisphere in half, it's called a hemisphere. So please remember that definition. Surface area of a sphere is 4 pi r squared. Now, where did this come from? Because it's basically 4 circles. If you've ever seen like a baseball busted open at its seams, it is basically 4 circles put together. Someone actually on YouTube took an orange, peeled it all apart, all the peel up, and then showed that it was actually 4 circles put together. Excuse me. So surface area of a sphere is just 4 pi r squared. So then when we plug in or have an example of it, easy peasy. R is 8, so we plug in 4 pi 8 squared. You get 256 pi. If pi is already in the problem, doesn't matter. You can plug it straight in. Again, all of these are written in pi form just to make my life a little bit easier. You can type in the calculator just as you see it and get decimal answers that are equivalent and be fine. In 2 and 4, those D's, remember, mean diameter, so we take half of that and then plug it in our formula. If you have any questions about the surface area of a sphere, now's the time to ask Miss Lewis. A hemisphere is half of a sphere, but the definition or formula for the total area, the surface area, is 3 pi r squared. Well, where does this come from? Well, half of 4 pi r squared, 2 pi r squared. So where's the 3 coming from? Well, that's because, remember, surface area is covering up the 3D solid. So the 2 pi r squared only covers the bottom part of the sphere. It doesn't take into account the top surface area, that great circle that's up top. It would be like covering the bowl, the bottom of the bowl, but not the top. So there would be no lid on the bowl, basically. So that's whenever we add in that top lid. So that's our pi r squared, which gives us our 3. So hemisphere is 3 pi r squared, not 2. So keep that in mind. So a couple problems of that. Plug it straight in. Whenever you're given diameter, take half of it. These answers are written in pi. You can write them in decimal form and be completely okay. Most of the time, it's 2 decimal places, as always, so keep that in mind if you're doing decimals. If you have any questions about a hemisphere, now's the time to ask Miss Lewis. The next thing is volume of a sphere. It's a kind of quirky little formula. It is 4/3 pi r cubed. It is pi r cubed because, remember, volume, we're technically multiplying 3 things. In this case, all we have is a radius, so that's 3 radii. And the 4/3 is just the coefficient. So looking at our pictures, we have some interesting problems. The first one, you're given the radius, so you can plug it straight in. Easy peasy. If you're given the diameter, you take half of it, you plug it in. Easy peasy. The third one, same thing. Radius, plug it in. The second and the last one, however, are very interesting with them because they are given C. If you remember, C is circumference, and circumference is either pi d or 2 pi r. So in the first one with 25, if I let 25 equal 2 pi r, because remember, that's what I need in my formula is a radius, that would imply that r is 25 over 2 pi, which is what I plugged in here. When typing this in the calculator, be very careful. Make sure you put parentheses around everything, and you would get 2604.2. If on this one you have 35, you do the same thing. It would just be 35 equals 2 pi r. Divided by 2 pi gives you your r. Plug it in the formula. You get 7145.83 repeating. If you have any questions about the volume of a sphere, now's the time to ask Miss Lewis. Hemisphere is half of a sphere, as we have stated before. This time, your formula is 2/3 pi r cubed, and that comes from, if I take half of 4/3 from my formula, I get 4/6, which reduces to 2/3. We are not concerned about covering up this bowl. We are just concerned about filling it up, so we don't have to take into account the actual top circle. So it's literally just 1/2. So then, plugging in our formula, in both of these we are given diameters of 6 feet and 80 meters. So we take half, plug it in our formula, we get 18 pi, or an equivalent decimal. Here, 80 divided by 2 is 40. Plug it in. You get 42,666.7. I believe, if memory serves me correctly, it's 6 repeating pi, or again, type it all at once and get the equivalent decimal. If you have any questions about hemispheres, now's the time to ask Miss Lewis. This topic is the last topic in your unit before your test tomorrow. You will spend the rest of class reviewing all of these formulas and any type of word problem that may come up, where you might have to draw a picture or compare and contrast different solids with each other, the rest of class. Tomorrow's your test. Remember, the first part of the test is matching all your formulas up, so make sure you have those down in your brain. The rest of the test is applying those. Some other things, remember from last Friday, that could come up on your test are all the platonic solids, so the tetrahedrons, hexahedrons, all those little hedron terms. Euler's formula, so F plus V equals E plus 2, and applying it could come up. Anything that we've talked about since last Friday can be on your test. So please make sure you get those formulas down, know how to apply them, know how to use the Pythagorean theorem to find sides that are missing of what you need. And all of those questions need to be answered today before your test tomorrow. Good luck, and I'm looking forward to see how well you do on the test.